And good morning or hello to everybody in different time zones around the world. We're going to go right into this first session. Just a very short introduction to say that, of course, we don't want to have tube failures in our HRSGs. And Bob and I spend a lot of time trying to address the mechanism and the root cause of tube failures. But unfortunately, they still continue. And in those cases, we usually call for Bill Kitterman. And we've asked him to come along today to give us some of the best practices with regards to tube repair clinic. Bob and I had him come to to two of the other HRSG forums that we run. One in Europe called the European HRSG Forum, and the other one in Australia, the Australasian Boiler and HRSG Users Group. They went down very well, so I'll just hand it straight over to Bill, who will introduce himself. Thanks, Bill.
Thanks, Barry and Bob. Good day to everybody. I know we're talking to a lot of different time zones. One of the things I want to preface this presentation on is it's a primer. We'll get into some detail, but a lot of it is basic 101. If you need any additional information, please, my name and contact will be at the end. The other thing I want to apologize for, especially to our guests that are outside the US, if I use any slang or vernacular that you're not familiar with, please let me know. It's not intentional, it's just the way I've learned the business. So, okay, the title of this is Repair Procedures, Good, Bad, and the Ugly. I guess first I want to do is just start as a quick introduction of who and what Bremco is. The company was started in 1976, and we've been working in the HRSG market since 1993. We also have a significant experience in 91. As of July 1st, we've become part of the SVI industrial family, which will allow us to provide a greater scope and breadth of work to all combined cycles and simple cycles. As you can see, SVI has their strength in inlet and outlet, inlet and exhaust, do a lot of valve work, catalyst repair and replacements. And that's just a brief description of who and what we are. A tube leak, excuse me, I'm sure you've all seen this dreaded picture. And here's just a few examples of the different tube leaks. Here's an example of a good repair. As you can see, the weld is, well, unfortunately, we can't really blow it up, but it's a good clean weld as opposed to some of the other ones we have seen. There's a bad one where weld has just been piled on top of each other, and you can see there's no direct relation, and it actually creates some stress risers, which will have potentials for other failures. In this particular, on this uglier one, you'll see there's square. I know the NBIC and ASME have made the statement that there's not as much concern as there used to be, but there used to be major concerns for square repairs for stress risers, and we don't like to do that. This is probably one of the ugliest repairs we've ever seen. Unfortunately and fortunately, it didn't last, but you can see someone just gobbed up a bunch of weld to make it stop leaking. What's important for everyone to understand is how their unit was built and what type of design and what type of weldments that they have through their headers. These are the different, excuse me, these are the different styles that we've typically seen. And we've got quick drawings on all of those, as you can see, and we've got some more detailed drawings here. But it's important for you to, as an operator, to understand what type of weld you have. So when your contractor comes in to do the repairs, you understand exactly what method they need to do. Here's a stick through with a J bevel. a socket set. We tend to see a lot of socket seats on the units now. That probably is the most popular. This all has to do with also how you would take out the tube when you need to make any repairs into the header, that you understand exactly how the tube was attached to the header. The extruded header, excuse me, we don't see as many units that have the extruded header, but we are seeing a substantial more repairs based on the extruded header and a lot of cracking right in the baseline of the extruder. Let me see if I can do this correctly, guys. This is where we're seeing a lot of the repairs right here. I don't know the exact reason why. That's why we have the experts like Bob, Barry, and Jeff Henry and the HRSTs of this world that have the ability to do the actual root causes. One of the issues that we've talked about quite a bit is because of the amount of time that you guys have, you have to keep these things operational. We seem to have not had the ability to actually take the samples out and do root cause analysis and truly to figure out the cause of the problem to stop it repeating. It makes sense to take the extra time in the beginning of your outage or during your outage to take the tube sample out correctly and have it shipped off to determine the root cause. It'll save you a lot of time and trouble in the short end. I have to speak a little bit about Bremco, for example, because this is what we do. To be a tube welder for Bremco, you have to have the ability to weld in a mirror. Because of the tight spacing for the tubes that we find in these units, probably 80 to 90% of the welds need to be mirror welds. And to be qualified as a tube welder for us, you have to go through our test jig, which, as you can see, doesn't allow the ability to cheat. So you have to set up your mirrors and do mirror welds. And again, to become a tube welder, that is something that you need to do. And you should check with all your contractors to see if they have the ability. Otherwise, you end up with the gobs that you've seen on the earlier photos. And here's just one of our guys performing the test, performing it the actual weld test itself. Obviously, the first and most important thing to do is to find the leak. What section of the unit? Is it lower, upper, elsewhere? Where we see a lot of the, in the actual unit itself, we're seeing a lot of tube leaks in the tube tie areas because they've been, because of the cycling systems, the cycling that everyone has to go to, you get a lot of wear and it's worn a lot of holes into the tube, mid-tube. But these are typically where we see the leaks occur, and our customers, excuse me, will. Well, one of the things we've seen a lot of customers do is using the sonic method of finding the tube leaks, which greatly cuts down on the time that we have to go through and pressurize and find the actual leak itself. So the sonic has worked really well for a lot of customers. Now, I know we're addressing an international audience, but typically these are the steps that we have to go through when we make a code repair. We have to go to the national board, meet their requirements, state or local jurisdictions, and the authorized inspector, both the customers and ours, and then what the insurance requirements are. Once you've identified where the leak is, what process you're going to use to make the repairs, you have to identify which process how you're going to actually get to it. These are the four methods that we typically have utilized through our experience. One is obviously raise and lower the panels, jack the panels apart, cut your way in, weld your way out, and plugging. And we'll do a brief overview of all of them. Raising and lower the panels. Here's the steps that you have to identify and make sure that all have to be taken. You have to cut all the jumper piping and the drains and the vents. You have to cut any of the restraints that are holding the panels together. And if you're working in a high chrome area or a thick header, you have to plan for stress relieving. Typically in a 91, you'll have to stress relieve on those drains, jumper piping, and the vents. So the next part is obviously having rigging points to move the panel itself. I kind of cheated on this one. It isn't really this is actually a picture of a panel replacement, but this shows you the type of movement that you have to do for a panel to raise it up or lower it so the crews can get access to make the welds. And typically what we've done is in a staggered panel, we've cut the, we jumper them. Either we drop one and raise another, so we have the ability to work at 2 panels at one time. As you can see here, we're finishing up and we're reattaching the jumper piping, which will go from panel to panel. Okay, now here's jacking the panels apart. The times we typically use this is when the access, it's in the middle of a bundle and we have the ability to access the basement, as we call it, to get to the panels, but it saves without cutting our way in and out the whole time. You can see the steps that need to be done, obviously cutting the restraints, cutting the drains, and then blocking the panels so they don't move. Here's an example of where we would use a spreading the panels. Essentially, you can see where the leak is located. We'll cut the jumper piping on HP Superheater 3 and 4. We can typically, where the location of the restraints are, will typically allow us to move the access enough so a guy can get in there, and then we'll block it. And you can see here where we've just welded an access point to clear so the guys can get in and fix the tube leaks as needed. Cut your way in and weld your way out. The parts that you have to account for is you need to make sure you have the proper amount of tube, because you have no idea how much you're going to cut it out until you get into it. It's typically done in a V pattern. You might, because the guy has to climb in there to make the cut, you might cut on the first row, again, depending on how deep it is in the bundle, you might cut out 6 or 8 tubes and then obviously go 6, 4, 2, and to get to the 1 tube, because the welder has to have the ability to make that weld and get to that weld and be comfortable making it. Obviously, the prep is important when you're doing a replacement. As you can see here, what ended up happening is the backside had the leak, so we ended up cutting the tube, but now we've got to replace, we ended up cutting the tube out. Then we had to, we had to cut this tube out, obviously, to make the repair on this leak, which is right here. So, and there you can see when the tube has been put back in. The other issue that comes up too is obviously these tubes have to be definned to allow us access to make the welds. And that's also a bit of a time-consuming method, but it can be done. Plugging. In our method, in our feeling, it's the least desirable method. It has strong code involvement and requires the highest level of skill. Typically, we'll see when we do any plugging, and we've only done 2 since 1993. it has a strong potential for stress relieving once you cut into the headers to actually make the plug. And you can see, obviously, here's a plug that's been made. It's important that you buy the proper tube plug and have it tapered in the correct method. We typically try to do it from the header side. Okay, we have seen people that have plugged from the gas side, but we typically would prefer, for a variety of reasons, which we can discuss later, on why we would plug through the header into the tube. And here's what we feel is the proper header plug. As you can see, it's rounded, no sharp edges to create any stress risers. The newest, excuse me, as the units have gotten larger and the materials have changed, we've typically seen a lot of 91, 92, 23 have created significantly number of repairs. And one of the things customers need to understand is the true downtime. The welding, and it's not uncommon, the welding is the fastest part of the procedure. It might take you only an hour or two to do the actual weld, but you're still going to be down for 24 to 36 hours because of the stress relieving and the other issues that are involved in making those repairs. It's kind of hard for the customer to understand, but based on code, these are the things that we have to do. This is just a brief chart outlining where code stress relieving requirements and what the responsibilities are. This happens to be, just for carbon and those kinds of things based on thickness, but obviously 91 has its own responsibilities. PT 91. Since we've begun working on 91, we've had to modify our 91 weld procedure 4 times as the information has evolved into the type of repairs that need to be done and the research that NBIC and ASME and EPRI have spent a lot of time with, and it involves tightening of the specs. When we first started looking at 91, it was considered a P1 material, so essentially anyone could weld it. Anyone that was a qualified welder, P1 to P1. It's obviously since evolved into a highly technical welding requirements with very tight pre and post weld requirements. It's also one of the other things that we found is the weld wire requirements have tightened significantly since we've begun welding on 91. Here are just some of the quick key 91 features. Obviously, you have to maintain the preheat. And one of the things that's an interesting requirement is your wrapping, to make sure that you have wrapped that to maintain the heat. It's quite an art, and we've got some very good contractors out there that do this. While some contractors will do their own heat treat and stress relieving, I will tell you, as Bremco, we farm it out to professionals. We feel that while we have the ability to do it, we would prefer to have people who do it every day and understand it. The requirements obviously are to understand and meet D1010 requirements for wrapping. They should have the ability to provide you wrap specs with the drawings, and the ability to monitor and fix as needed when they lose a thermocouple or something changes from their weld. They should be able to monitor that on a 24-hour basis and have the ability to make the changes. One of the things I was taught by a stress relieving company is when you receive your heat treat charts, is some of the companies give you a clear, just one line to show you their heat treat analysis, or their ramp up cycles and everything else. And you'll see everything falls along the line. Question that immediately, because you have different thermocouples on there. So you should have multiple lines that identify the readings that the different thermocouples are getting. With 91, we, again, hardness testing is a very important requirement. And what we do is we do both a pre and post heat treat to make sure that that 91 falls within the applicable hardness grades. We have run into situations where we've had soft 91 and we've had to make some adjustments based on, and we found the hardness testing to be soft based on the initial inspections, and then we had to make some adjustments to the repairs that we did for that. Okay, here's an example of cutting your way in. On this particular unit, we had to go 6 rows deep to get to the tube repair that we had to do. And as you can see, we V'd it down so the welder can get in and make the repairs. Where it becomes even more complicated is if it's, for example, a 91 repair, where we have to wrap everything and heat treat it and keep the preheat on it. And we have to do each row. This is where it becomes very time consuming, because even though we're 6 rows in, we have to heat treat each row as we walk out, and it creates a long outage. As you can see, here's the tubes wrapped with thermocouples and doing a post-weld heat treat. There are some alternatives, and one of the alternatives that has been approved is weld method 6. Now this allows repairs to tubes only, allows repairs without post-weld heat treat. As you can see, it requires butt welds only, and it has to be, these are the minimum preheat temperatures. I will tell you, we typically run it hotter than that. We typically run it about 400 degrees to do it. And essentially what we do is we paint the tubes, okay, with the nickel-based austenitic, and then put it on. We have done approximately 100, 120 welds with this weld method 6, and we've had one failure, I guess, that we had to cut out and perform in the traditional method. The beauty of weld method 6, obviously, is when you're down and you need power immediately, you have the ability, it'll minimize your downtime significantly. As you saw on the slide before, if you have to go 6 rows deep and that happens to be 3 headers, you'd have to do a post-weld heat treat on each one of those. And a post-weld heat treat is typically 14 hours per post-weld heat treat. So you're now talking, 4 days just to get that out. Where with the weld method 6, you can probably get the whole project done in a day and a half to 2 days. There is also a supplement 8, which is for thicker pressure parts, which will allow us headers, pipe, etc. One of the major concerns about Bremco has not yet performed any repairs using supplement 8. Our concerns, while we have no problem doing with any in the pressure in the box itself, in the Hrsg itself, this is also applicable to a temperator piping and piping outside the unit. At this point in time, we're just not comfortable performing supplement 8 outside of the unit for various concerns. It does require documented inspection intervals to make sure that the repairs are holding up, where weld method 6 does not. but it's another option, again, based on the time to provide the power necessary for your units. The last thing I kind of want to touch on is the requirements by the NBIC. And again, I apologize, this is pretty much based on the US specifications. But the only requirement the NBIC has is that an R form is submitted, which is for your repair forms. However, there's a huge amount of information that you as the end user don't have once an R1 is submitted. And one of the things I would push for is that you ask whoever your repair contractor is to provide you this information, as it'll help you as you're making future decisions and moving your projects, try to identify any trends. Let's see. Here's what we use as standard, a standard code package. It's your job traveler, which in essence is the welder's job orders. It tells them what rod to use, what method to use, and how to make the repair. It'll also identify any hold points for inspections or anything along that line. You should, in that code package, you should also have a data report, which will back up the choices made by the travelers. It's essentially what your unit is and how it was constructed, the materials, etc. And then it'll go to what weld procedure that the contractor is using or used on your repair, to identify the methods that they used and the weld rod and everything else. Then you should have a weld continuity log, okay, that highlights what the welder's skill set is and what they're qualified for. By code, all these welders have to weld in process every 6 months, and our weld log is obviously updated weekly depending on the number of welds that we do, but it assures you that your welders have the skill set and have the ability to make any of the repairs that your weld procedure and your job traveler call for. Material receiving report is strictly you're verifying that the material that you're using, meets the data report and is a qualified replacement material. Then it's obviously mapping and photo identification to identify what you've done, where you've done it, and how you've done it. The pressure test record is, we use it either as a hydro, or in other cases, we'll do VT, PT, MT, RT, depending on what is the best NDE applicable at that time. And then finally, it's your R1 and R2 form. Oops. I guess, well, thank you for your time. It's a little bit quick, but I'm kind of used to giving presentations in person so I can answer questions or see where things are going and allow me to take questions during the thing. But anyway, thank you for your time. And if there's any questions I can answer, please let me know.
Bill, thanks very much. Very nice presentation as usual. And you've left plenty of time for some discussion and questions. So we received 3 questions before the meeting in registration, and we have got a couple of questions through the chat. So what I'll do is I'll ask the various people to. I checked that they are here and registered. So the first one is if Scott can unmute him, Donald Maffioli from NIPSCO. Don, can you verbalize your question, or else if you want me to read it out, I can do so as well.
No, I'd be happy to ask. we've done some LP economizer replacement, and I just wondered if that is generally where you're seeing most units having approach temperature issues and subsequent failures, is in that section of the boiler.
Actually, the two major areas we're seeing them are in the LP, typically an FAC situation, but we're also seeing a significant number in the superheats. A lot of that, again, we feel, and this is anecdotal, I'm not trying to engineer anything, but we think a lot of it has to do with cycling and condensate buildup, those types of things. But we either see the FAC still seems to be the root cause of a lot of the problems we see in the LPs, and superheats, we see a lot of condensate buildup, which causes the failures there.
Okay, thank you.
Well, that's a very interesting question, and Bill's exactly right. FAC is still occurring too often, and he mentioned in the LP evaporator sections, but sometimes we do see it in the economizers due to steaming at the top, at the return bends at the top. So I wondered what your mechanism was in the LP economizer. Do you know that, and could you share it?
What we actually ended up having was a low approach temperature. We had some fouling on the tubes. We went after it with an ice pick cleaning, which caused some issues. We kind of shot ourselves in the foot there, and didn't get a good cleanup down on the header, and had a failure down on the bottom end, right on top of the header. So.
Oh, okay, good. Thank you. Thank you. So, yeah. So, Bill, there is another question here that's in the chat, but this gentleman also provided one pre the meeting. So this is a gentleman, Andres Vernes. I think he's from Latvia, Hrsg. And if Andres is here, perhaps you can state your question, please.
Yes, my question was, can you support outage overseas in the European Union? And if yes, what is your typical reaction time? Thank you.
The answer is yes, and it depends, I guess. I guess the best thing is, if you would, I've included my email and everything else. We can, you could send me an email. We'll talk about it and go from there.
Yeah, that's good, Bill. We try to avoid the commercial side, but Andres, you can contact Bill if you want. If you want to make contact, just make contact with me or Bob. That's fine. And you had another question about how to find leaking tubes in the superheater. Do you want to raise that one?
Yes, it's a big issue for us. Actually, we were lucky to have leakage on the first row, but I'm just wondering what to do if the leakage is downstream somewhere, and you visually cannot visualize it. How to find it?
One of the things that one of our customers uses that has had a significant number of superheater leaks is a sonic method. I will tell you, initially I didn't believe it, but they've had a lot of success pinpointing the tube leaks there, and been pretty accurate.
Bill, this is Bob. When you say sonic, is this the portable directional microphone, or is it an installed monitoring system?
It's an installed monitoring system at this particular account.
Yeah. What that means is there are systems that put basically microphones on waveguides through the casing, on headers and pipes within the boiler. And then this array of sensors actually listens for and can hear the sound of a leak. And then the signal processing triangulates to the location of the leak. So those have become pretty effective. You can contact Bill or us, and we can give you some more information about where that might be available. Bill, do you know of anyone successfully using the amplified directional microphone with air on the system?
I can't say as I do, Bob. I mean, I'm not sure what everyone uses, because a lot of times they've identified where it is for us, so we just say, okay.
Yeah. Right.
Good. Yeah, okay, thanks, Bill. Thanks, Bob. Bill, there's an anonymous question here, so I'll read it out. The Bremco host, that's you, stated even with going 6 deep tube rows for repairs to T&P 91 material, Bremco would rather not perform a tube plug through a header for 91. With all the angles and tricky heat treatments involved, with all the tubes that are being welded and heat treated, isn't it an easier repair to cut into the upper and lower headers and just plug the one tube leak instead of having, hold on, just got to move the thing down, instead of having maybe 10 to 15 new tube wells with preheat and post-weld heat treatment and maybe some inspection and NDE?
Again, typically it's based on customer choice, but we would, and I'm kind of old school in this, is I don't understand why you would plug, a tube. They're typically designed, and I've talked to some of the OEMs and I understand their statements, but I'm just not sure about flow characteristics once you start plugging tubes and doing those kinds of things. I'm just not sure what it does to that. So we would prefer to avoid it. In those particular cases, those are the customer's choices that have decided they want us to cut our way in and weld their way back out. I don't know. It just concerns me. They were designed to follow a certain flow pattern, and Bob Anderson has done a lot of studies on this, where he's put thermocouples all over tubes, and what you think is a riser becomes, isn't a riser anymore. It's a downcomer. So it's just a personal preference that we would do.
Yeah.
If a customer said to plug it, we'd plug it.
I can add a bit to that on a couple of points. To Bill's point, if you plug a superheater tube, let's say you had a failure near a sidewall or a gap between modules, probably caused by that tube running hotter than its neighbors because it's near the gap where the gas is bypassed. So you plug that tube, you've now taken it out of service. It's no longer being steam cooled. So the hot bypassing gas temperature is now impinging on the adjacent tube. And so if you were to plug it, you have a very good chance that that's the same damage that was caused on this failed tube at the end will just progress to the next tube in the bundle. If you plug that one, it'll move to the third tube. So that is a real issue in a superheater or a reheater on the hot end. In the back of the boiler where you have carbon steel headers, if the window you cut in the header is properly shaped so it has no sharp corners to make stress risers, you can make a durable window weld in a header, carbon steel header, and it'll live. It's not the same result when you try to do that on a P91 header in the superheater or reheater. These dozen or so tube butt wells that you make take a lot of time and are expensive if they're done properly to weld in and weld out, but they are very reliable repair. So if it's executed correctly, you're very likely to have a future problem with those wells. On the other hand, if you cut a window in a P91 header, you inevitably end up with two long seam wells in that window running the length of the header for some distance. So even if you make round ends on that header plug, not the tube plug, but the window you cut in the header to get access, you've essentially got now long seam wells in a P91 pipe, which has some significant weld strength penalties associated with it. And I like this picture here. So under the current code and material allowable properties for P91, I'm not sure that, depending on that header thickness and the stresses and all, code might not even allow you to have that longitudinal weld on that header. So the more reliable thing to do is to weld on the tubes and leave the header alone. It's not the cheapest thing to do or the fastest thing to do, but it's the reliable thing to do.
Good, thanks, Bob, for the additional. There was one comment from Mark Marble in terms of the location thing that we were just talking about. He said that we use a portable sonic imager. Mark, did you want to say anything else?
I hope so. I'd like to hear a little more about that.
Yeah, we have a,
Okay.
I'm trying to remember the name brand of it, but we have a sonic imager. It actually looks like you're looking at a FLIR thermal imaging camera. It turns the sonic images into that type of a display. It helps you pinpoint the leaks. We do that with 3 pounds of pressure on the boiler, so it makes it easy to find.
Yeah. So you've already used a sky climber or scaffold up or whatever to get in the area, or will it work at a much longer distance?
It will work in a much longer distance, but you have to get closer to narrow it down, if that makes any sense. You can get the general location to know where to build the scaffold, and then you get up there and you pinpoint it with it.
Oh. Well, that's interesting. I'd heard of, in the old days, you had to just have your earphones on and try to listen to where it was loudest, but very interesting. They've digitized that display.
Yes.
Thanks.
Very interesting. So there's another related one. Tam Chelvan from Siemens has 2 questions. And Tam, if you just follow up with your with the one on the acoustic leak detection system first, so it'll continue follow that question. That'll be good, please.
Hello, can you hear me?
Yes.
Yeah, I have 2 questions. One question and one comment. The question is for the repair company, do you do the total package, including the heat treatment and the NDT scope, or you are providing only the welding service? Because some of our customers for Siemens, they want a total turnkey scope. So that's why that question is. The comment on the tube leak detection system, we have installed the company, we worked with a company named Mistra's 555 acoustic system. They have a bunch of electrode kind of sound acoustic probes. They install it in opposite walls at a different section where you need to have these, if I have a 6 bundle along the length of the Hrsg, in between those bundles, at the bottom area, they install this probe, and they transmit sound signal from one side to the other, and then they monitor the signal. And that signal with a certain decibel is normal, that's fine, no leak. And then all of a sudden, if there is a leak, that signal goes much higher and then stays there until the leak is fixed. So that kind of actual commercial installation we installed in 2 Hrsgs, and we have results. And if there is a room for presenting those results, we could present those and what involves, what scope, what welding, all those details we can provide. So those are the 2 items I have.
Well, I guess to answer your question, that yes, we would provide the total package. However, we feel just from an efficacy standpoint, we would prefer to use, it will still fall under our package, but we prefer to supply outside heat treating companies and outside inspection companies to give the customer the satisfaction of knowing that it wasn't done, that it was done correctly. We have the capabilities of performing both in-house, but we don't.
Thank you. Yeah.
Thanks. Thank you, Bill. The next question is from my good friend Charles Turner in Canada, in Toronto. Charles, if you're still here, please.
Yeah, it's we've always had a struggle with maintaining back purge, especially for through wall repairs on tubes and headers. I'm just wondering what Bremco's approach is as far as continuous purging, dams, brace paper. What has been your most successful for the full circumferential tube repair?
Dewar's bottles. To be honest with you, we've had it. We've back purged the units with Dewar's bottles. We do have a procedure to use Solar Flex on it, but typically what we'll do is we'll back purge with Dewar's bottles.
Dewar's bottles.
They're just large
Yeah.
argon bottles. That's essentially what they are.
Okay. Just lots of gas.
Yeah, we flood it. We typically will flood it.
Okay, and just
I thought you meant Dewar's Scotch. I'm glad you clarified
Well,
that.
that's after. Yeah, no, they're large liquefied argon that will back purge the whole section.
right, and you just be careful on the pressures, you don't get blowout on the weld.
I'm sorry, I missed that.
So you just careful with the drafts and the and pressurization so that you don't get boats on the weld.
Yeah, typically, I mean, obviously, we like, if the unit has a stack damper or something along that line, we want that closed to eliminate, the drafts that we get in there. The guys also build up, their little, I don't know, enclosures to make sure that we minimize the drafts.
Okay. All right. Thank you.
Yeah, Charles, thank you. The next question is from my friend Armand Durant, who's with Genesis in New Zealand and is one of the attendees at the ABHUG that we have in Australia. Armand, are you still here, please?
Yeah, my question was about if you raise or lower any hobs, is there any issues with getting the tube hobs or the wraparounds or tube ties caught on the adjacent hob?
Yes, yeah, that is obviously one of the bigger issues. We a lot of times we'll slide them because typically there's a little space, so we'll build a rig just to move them a little bit so we minimize the damage, because a lot of times even the fins are so close that they'll fetch up on the fins too. But we have to have the access to cut the tube ties. And it's a function of which vendor's Hrsg it is, because all the tube ties are different. So, and seismic restraints. So that all comes into factoring whether we can raise and lower the harps or panels.
All right. And just another question I had, I guess, obviously for
Yeah,
you
go
guys
ahead.
doing a lot of tube-to-tube welding, have you ever considered autonomous welding, like having an orbital welder to make that easier, or is that not a solution?
Well, we have the part, there's two issues with it. Number one, unfortunately, my guys are a lot of John Henry. So once, and that's a story here, but once typically they're one-offs or two-offs that you're doing. So by the time you set up the welding set the machine up, the orbital up, the guys have already done the welds, because you're only talking, at most usually 150 tubes, min walls. And the other thing is, there still is an issue with spacing to get the head around, because we've looked at it quite a bit when we've had to do total header replacements. That was one of the options that we looked at. It's still where it becomes a little bit concerning is that you don't have the spacing with the fins and everything else, the full 1.5 inches to get it around, to get the head around.
Yeah, that makes sense.
I see you in November for AppHug. The next, there's a clarification here by Mr. Moorman, just saying that the tool that Mark was talking about to find the tube leaks is FLIRI 900, and it's an excellent tool to find leaks. If you want to say anything else. Okay, so, well, Bill, we've only got a few minutes left, and there's just a couple of general questions here. And the first one is from Chris Tompkins at Transalta, and it's a sort of general question about determining locations for potential tube selection samples, I guess.
Yeah, I mean, again, that's where I would recommend, obviously Barry and Bob, because they're really the ones because it's typically a chemistry issue or something along that line that causes it, and they just tell us which one to take out. We take it out and put a new one in.
So it could, well, of course, it could refer to quite a number of different circuits in the in an HRSG. But if it's referring to HRSG HP evaporators to try to prevent this large increase in hydrogen damage and under deposit, there is a guidance document, an IAPS guidance document for that. That you can see the IAPS logo just behind my head here. And you can go to the IAPS website and download it, and that'll tell you exactly where to take the tube samples from and how to take them and how to analyze them. I'm not aware of other documents that do that for other sections, but the HP evaporator is one of the most important ones to stop this under deposit corrosion taking place. Well, thanks, Chris. There's another sort of general one from Marcello Lupinuzzi from MSU Energy. If he wants to ask his question, he was asking about maintenance frequency and points to include in outages, Bill. I don't know.
I think that one may be related to the attemperator, but I'm not sure because it doesn't say.
Oh, okay.
I have a quick question, Bill, if there are no others, Barry.
Yeah, go ahead.
Bill, on the extruded header, you marked that the failure is generally in the header itself, in the extrusion, rather than in the weld. How do you take that sample of that failure, and if you do, how do you get a piece to put back that is the same as the extrusion?
Well, what we've had to do, Bob, is we have taken out essentially right to the header, and let me just.
You convert it to a
right. We've converted it to a socket weld. Oops.
Okay.
I'm sorry, guys. Yeah, and we've converted it to a socket weld.
I see.